Greetings guys. We are starting with the topic sum to infinity. Now, I'm not going to go into much detail when it comes to issues of sum to infinity. But what we realize is that as series, especially geometric series, as they approach infinity, we have two cases. So when they approach infinity, we have two cases. That geometric series can either be divergent or it can be convergent. When is it divergent? It is divergent when r is less than -1 or r is greater than 1. Okay, and in this particular scenario, when we say it is divergent, what we will realize is that the sum to infinity does not exist. Okay, and then here when is it convergent? It is convergent when the constant ratio is between -1 and 1, but it is not equals to -1 and 1. Okay, if our constant ratio is between -1 and 1, we say that the sum to infinity exists. And the way to understand this really is that when we are saying that something is convergent, we are simply saying that that something is approaching a particular number. We can consider this one as an example: 1/2 plus 1/4 plus 1/8. If you keep on typing that on your calculator, you'll begin to realize that this is actually approaching 0. It's getting closer and closer to 0. All right. But if you look at this series, when we talk about divergent, we are saying it does not approach any specific number. Okay, an example of this would be 2, and let me try to find something that you can relate with. 2 and let's say 4 and let's say 8. So it doesn't actually approach a specific number. So convergent, we say it's convergent. What do we mean by that? We mean that it is approaching a particular number. I showed you an example that this series is actually approaching 0. Okay, you can test it out by typing as many values as you can, and you will see that it is approaching 0 as you increase with the numbers. As you go towards infinity, we are approaching 0. And we are saying that something is convergent. In other words, it approaches a particular number only and only if the constant ratio lies between -1 and 1. And then we say something is divergent only if r is less than -1 and of course r is greater than 1. But note again, r cannot be equals to 1 to -1, and r cannot be equals to 1. And the reason r cannot be equals to 1 is that, guys, when r equals to 1, let's say you have Sn equals to Rn minus 1, r minus 1. If r is equals to 1, this will be divided by 0. And if it is divided by 0, guys, that series cannot exist because it becomes what? Undefined. All right. So when you deal with geometric series, you can never have a scenario, or you can never have a case where r is equals to 1. I want us to look at this question, and you can pause the video, try it on your own, and see if you can be able to do it on your own. So before you you watch me do it, I would prefer that you try to do it on your own. All right, now let us look at what we have here. It says calculate the sum. All right, calculate the sum to infinity, and we have to highlight a formula that you use. The formula for sum to infinity is S infinity equals to a 1 minus r, but this is only on the condition that r must be between -1 and 1. So this is the formula, guys, that we use to calculate the sum to infinity. Okay, so now we know which formula that we are going to use to calculate the sum to infinity. S equals to a 1 minus r. Okay, calculate the sum to infinity of the geometric series. This equation is saying we need the first term, and of course we also need to know what is a constant ratio. So let us get into it. Okay, now this is a equals to 1 over 2. The most critical point or value we must find is actually r, and the reason we must find r is because we want first to ascertain that is it convergent, because the sum of infinity exists only and only if a series is convergent. Okay, so if r is between -1 and 1, then the series is convergent. So let us try to find r. They already told us it's geometric, so we're gonna say t2 divided by t1 is actually 1 over 4 divided by 1 over 2, which is just 1 over 4 multiplied by 2 over 1, and that is 2 over 4, which is 1 over 2. Now check the constant ratio, which is 1 over 2. Here's our constant ratio, and I want you to tell me, is it between -1 and 1? Yes, it is between those numbers. Therefore we will write that. Okay, we will therefore say, therefore negative that 1 over 2 is between -1 and 1. Thus the series converges and the sum to infinity exists. Okay, you have first to determine whether the sum to infinity exists or not. Then we can apply this formula. Sum to infinity equals to a 1 minus r, and of course that is just 1 over 2, 1 minus 1 over 2, which equals to 1. Okay, so this is then the sum to infinity. Let us just recall the steps. Step 1, I wrote down what is my first term. Step 2, I then said what is my constant ratio. Okay, step 3, we then asked that is my constant ratio between -1 and 1. Okay, this, if it is between -1 and 1, means it converges, and if it converges, it means what? It means that the sum to infinity does what? It exists. Okay, so that is very important for you to do that. I hope that makes sense to you. Let us look at this one. Right, let us look at this one. I'm not gonna dwell too much on these questions, so I'm just gonna look at this one. Again, you are having this, and they are saying calculate this if it exists. Look at what's at the top. What's at the top, guys? Sum to infinity. That is infinity. Again, so it means that you're actually looking for what, guys? The sum to infinity. So now what I'm gonna do is that I'm gonna just take this symbol, which is in sigma notation. I'll say infinity equals to n equals to 1, 2, 10, 1 minus n, and that is 2, 10, 1 minus n, and that is plus, sorry, that's a mistake. First value to be substituted is 1, and then followed by second value to be substituted is 2. Okay, second value to be substituted is 2, and the last value to be substituted is 3, and we say dot. Okay, and then here you'll get 2, here you'll get 0,2, here you'll get 0,002. Okay, what is the value of our first value is 2. Can we try to find r? Okay, and we don't know what type of series is this, so we are gonna have to do it twice so that we can be able to ascertain. So we're gonna say r equals to T2 over T1, and we are going to do the same and say R equals to T3 over T2. And therefore, if you notice, T2 is 0, 2, T1 is 2, 0, 0, 2 is our T3, and then 0, 2 is, of course, and here it's 0, 2. Sorry about that. Making a lot of mistakes, but I hope you're following me. And so this is equals to 0, 1, and that is also equals to 0, 1. Okay, therefore we conclude, therefore this is a geometric series. Okay, and what we notice, because of the infinity sign at the top, we say it is an infinite geometric series if we are being more accurate with the question. Now, what we want to now ascertain is that, does the sum to infinity exist? And remember, guys, the sum to infinity exists only and only if the series converges. So in order for us to know that it exists, we first have to find out, is our R between what? Between -1 and 1. What is the value of our R? Well, that is the value of our R. And it can be clearly seen that our R is between -1 and 1. Therefore, thus the series converges and the sum to infinity exists. Okay, so we can be able to calculate the sum to infinity, which is a 1 minus R, that is 2, 1 minus 0, 1, which equals to 20 over 9, which is equals to 2, and we can just leave it here. We can just leave it there. And in this question, they told us that we must convert the recurring, and remember the word recurring means it is repeating. Okay, it is repeating, and normally we see that with dots on top of a number, into a common fraction. So we are to convert this recurring decimal into a common fraction. In other words, we must write it in the form of that, where b cannot be equals to 0, because when b is equals to 0, this thing becomes undefined. All right, so now let's just try to establish what we have. Guys, I want to take a simple example. 2, 2 is the same as 2 plus 0, 2. Okay, so this is the logic I will be using to write this recurring function. So this is 2, 5, 3. What numbers are repeating themselves here? Numbers that are repeating themselves here is what? It's 5 and 3. So 2 doesn't repeat itself because it does not have a 2 at the it doesn't have a dot at the top, but it's only 5 and 3, 5 and 3, 5 and 3, repeating itself infinite times. Using the logic I've shown you earlier, we can write this as 2 plus 0, 5, 3, 5, 3, 5, 3, 5, 3, dot. Okay, we can furthermore extend this and say this is 2 plus, now let's see, this is 2 plus, I can take the first 2 here, okay, the first block here, and I say it's 2 plus 0, 5, 3, and then I can take the second block here. I can take this, excluding this, then it makes it 0, 0, 0, 5, 3, all right, and I can exclude this entire part so that I'm only taking 5, 3, so that I have plus 0. How many must I exclude? 1, 2, 3, 4, 0, 0, 0, 0, 5, 3, and you can continue with that until infinity. Okay, now if you notice here that 2 is not going to infinity, so we can't find the sum of infinity of that. But this here, guys, is going all the way to infinity. We can try to find out if this can we find the sum of infinity of this. And first, in order for us to find the sum of infinity of this, we must first ascertain if the series converges. So the first thing we want to write is, okay, what is the value of A? It's 0.53. Now we want to know what is the value of our constant ratio. So we will say T2 divided by T1, and we want to first find out if it's geometric in nature, and we'll say R equals to T3 over T2, so that is 0.0053. all right, 0.053 divided by 0.53, and here we have 0.000053 divided by 0.0053, and both of them will give us 0.01, and it will give us 0.01. So what we have concluded here is that therefore this is a geometric series. Okay, now we want to find out, does it converge? Yes, it does converge, because 0.01 is between -1 and 1. Therefore, since 0.01 is between 1 and 1, it follows that the series converges and is thus an infinite converging geometric series. Therefore, the sum to infinity exists. Okay, because remember, the sum to infinity only exists if this property holds. If it doesn't hold, then the sum to infinity doesn't exist. Therefore, we say sum to infinity equals to A 1 minus R. What was the value of our A? It was 0.53. What is the value of our R? It is 0.01. And then from here, you will find out that our answer is actually 53.99. So therefore, 2.53 ... Remember, this was 2 plus 0.53535353. All of this can be written as 2 plus 53.99, which is just the same as 253 2 whole number 53 over 99, because 2 plus that will just give us 2. That's why we wrote it that way. I hope it does continue. We then look at example 5. We are almost done. They say consider the infinite geometric series. Okay, so we are told that this is infinite, it's approaching infinity, and it is a geometric series, meaning we don't have to show that it's geometric series. We are already told that it is geometric, so those points are critical. All right, then they then ask you, for what values of P will the series converge? For what values of P will the series converge? Well, we know what we know. Okay, we know that a series converges only and only if the value of its R is between -1 and 1. Okay, so this is what I will write. The series P plus 1 plus P plus 1 squared plus ... will converge only and only if negative R is between -1 and 1. Okay, so let us find R. R is T2 divided by T1. All right, T2 divided by T1. So what is our T2 here? Is our T2, it is P plus 1 divided by P, and our answer is P plus 1. Therefore, the series will only converge. Therefore, this implies that in order for the series to converge, we know that R must be between -1 and 1. which implies then that p plus 1 must be between negative 1 and 1, since that is our constant ratio, which furthermore implies, if you apply the additive inverse, which furthermore implies that our p must be between negative 2 and 0. How did we get there? We simply said this is p plus 1 minus 1, and that is 1 minus 1, and that is negative 1 and negative 1. Meaning, in order for our series to converge, p must be between negative 2 and negative 2. Okay, so it will only converge if p is between negative 2 and negative 2. All right, so that's how you answer that question. Okay, B, assuming that the series is a convergent series, calculate the sum to infinity. Very simple. We know already, we are using the assumption, so we will say sum to infinity equals to a 1 minus r. Well, what is the value of our a? Our a is p. What is the value of our r? Well, we have just found our r in the previous question. It is p plus 1. So that becomes p 1 minus p minus 1, which is actually equals to p all over negative p, which is just negative 1. Let us look at the last question under sum to infinity. And it's an interesting question. You have to use simultaneous equations to solve this. It says a convergent geometric series has a second term, very important, has a second term of 8 and sum to infinity of what, guys? Of 36. So let us just state what we are given. We are told that the second term, it is what? It is 8. And we are told that the sum to infinity is what? Is 36. Okay, we know that we can write this as AR equals to 8, and we can write this as A1 minus R is equals to 36. Okay, now what is our task? We must determine the possible constant ratios. Okay, so now what I can do here, it seems here that I can make A the subject of my formula, so that I have 36 open bracket 1 minus r. If you just use the issue of cross multiplication, that's how I would have arrived at that answer. Okay, and here I can also make a the subject of the formula by simply dividing both sides by r, so that I have a equals to 8 over r. And now I have something to work with. I can call this equation 1, and I can call this equation 2. Okay, what you notice here, guys, is that the a and the a are the same. So this means that 8 over r equals to 36 1 minus r, since the a's are the same. Okay, we can further drag this topic and say this is the same as 8 over r equals to 36 minus 36r. And then we can get rid of the r by multiplying by r over 1 both sides, multiplying by r over 1 both sides, so that we have 8 equals to 36r minus 36r squared. Okay, and then of course we can write this in this following manner. We can bring this to the other side, so that we have negative 36r squared plus 36r plus 8. All right, we can multiply throughout. By negative, so that we have 36r squared minus 36r minus 8. And we can divide everything by 4. Yeah, 4 will work. You can divide by 4. Yeah, we can divide, and this is positive. We can divide by 4. Sorry about that. We can divide by 4 all throughout, so that we have 36 divided by 4, it is just 9, and then 36 divided by 4, it is just 9, and then 8 divided by 4, it is just 2. And it becomes easier to factorize this. We can open our brackets, and then this becomes 3r and 3r, and that becomes negative 2 and negative 1. Therefore, r equals to 2 over r, or r equals to 1 over 3. If you notice here, we just used basic simultaneous equations, and the strategy we used here is that we equated our two equations. Okay, so that's just a strategy we use in simultaneous equations.